All right, on to page number 2, solving these systems by graphing. So I think we did number 7 together already, but if you didn't, or you forgot to write it down, or you had to get something new, a new paper, you'll want to go ahead and follow this here. So remember that in both my equations, this is my b, which is my starting value. So my starting value for the top one is a -2, so I find -2 right on that y-axis right here, and I put my first point. The slope tells me how I move. So the slope is what's next to x, remember, if we look back at our notes. So I have two choices where to put that negative. I can put the negative with the 1 on top, or I can put the negative with the 1 on the bottom. So if it's a rise of -1, because remember the rise is on top, run is on the bottom. If it's a rise of a negative, we go down 1, and we would go right 2, or if it's a rise of a +1, we can go up 1 or to the left 2 for our run if it's negative. So I can move either way. So I'm going to choose to be here, and I'm going to go down 1 over 2. So down 1 over 2, down 1 over 2. And then I can go the opposite way. So I can go up 1 to the left 2. That way I can continue my line. And once I have them all, I just take my straight edge, or you can connect the dots the best that you can with what you see. Just extend it across the graph. So that way when you do your second graph, we can kind of see where it goes. Let's see. This one is going to start at a +2. So we put a dot at the +2 mark. And then we can, once again, we can either go down 3 to the right 2, or we can go up 3 to the left 2. So it doesn't really matter. I'm gonna go ahead and go down 3 because we want it to cross. So down 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. Oh, there we go, right there. It's gonna cross at this point. That's gonna be my solution. So technically I already know my solution without having to draw this line, but I'm gonna go ahead and do it anyway. So then I look at where this cross is, and my solution is going to be, I look at where my x-axis is first. So it kind of lines up with the number 4 right here on my x-axis, and then on my y-axis it's at a -4. So 4, -4 is my solution for that one. Number 8, do the same process. So I started a -3, which is here. And then I'm going to move up 1 over 1, 2, 3, up 1 over 1, 2. This kind of goes off the graph here. So I'll try to go down 1 to the 3 this way. And that way I have my complete line here. This one's a little out of order. Oops. There we go. All right, so then I'm going to do the other line. We've got, remember, a -x is the same as a -1x, which is a -1 over 1. So that's going to be my slope. But first I start at a +1. And I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. There's our solution. And then I just take my straight edge, and I go ahead and make my graph. And where they cross, that is my solution. So my solution is at, looks like 3 on my x and -2 on my y. All right, so once again, for the top, you've got those two as solutions, 4, -4, 3, -2, and you're good to go. All right, on number 9 and 10, this time we're solving a system by not graphing them, but by the equal values method. And so number 9 is nice because they're already in y equals mx plus b form. So what we can do is we just take each of these pieces and we put them next to each other with an equal sign. So we take 3x minus 5. We make that equal to -x. Now, remember that a -x is the same as a -1, and I'm going to go ahead and put that in so we don't forget to do something with that -1 later on. All right, so the first thing I have to do is get all my x's to one side. So usually I tell you to move the smaller x to the big X side. So that's what we're gonna do, is I do the opposite of a subtract 1x or minus 1x, which is a positive or plus 1x on both sides. Make sure the x's line up with the x's over here. So we're adding 1x over here. I'm just gonna rewrite what I have. So I've got 4x minus 5 equals 3. So then I go on step 2, which is this is just a two-step equation at this point. So this gets us there, and now we're just going to solve for x. So I need to add 5 to both sides. Draw my line. I've got 4x equals 8. And then as you can see, all we have to do is divide by 4. And we'll get our answer of x equals 2. So that's that first one. So number 9, there's the full work. Make sure you get that copy down. All right, so x equals 2. And so we're almost done. So this is one more step left to do. We have to take that 2, and that 2 is either going to go here or it's going to go right here for that x. So we just choose which one you want to put it into. I don't like working with negatives, so I'm going to go ahead and take that 3x minus 5 and put that 2 in for the x right there. So really what I have then is I have 3 times the x that I told you we need to put there, which is 2, and then I have to subtract 5, and that will be my y value. So 3 times 2 is 6, and 6 minus 5 equals 1. So y equals 1. All right, so then I write this as an ordered pair. And so we know that, y equals 1, right? And we know that x equals 2. So then I just put it in my ordered pair. 2 goes here, comma, 1 goes here for my y, and that's my solution to my system. And we can double check it. It's always good to double check. If you take the 2 and you put it there, we already know the top one works, but does the bottom one also work? If we put a 2 right there, we would have a negative 2, and a negative 2 plus 3 does equal a 1, so we know we're right. All right, that's one way you could always check it. All right, number 10 here. This is not in y equals mx plus b form. So this one's kind of a pain because we have to change the top piece into y equals mx plus b. So I'm gonna do that first right here. I'm gonna rewrite this so I give myself some workspace here. All right, so the first thing I'm gonna do is I'm going to subtract 2x from both sides. And remember, I can't take away that 2 from 5. I have to either put it in front or after, but I like to put mine in front. So I have a 3y equals negative 2x plus 5. And finally, I have to divide everything by a 3. And so this will give me y equals negative 2/3 x plus, this one's kind of a tough one to work with for sure. So 'cause I have to work with some fractions, which isn't the most fun, but I've got 2 fractions I have to deal with here. So now I have this piece, which is a negative 2/3 x plus 5/3. And then I have the this piece, which is 5 minus x. So I'm gonna rewrite those side by side because that's what we do for equal values. So 5 minus x equals negative 2/3 x plus 5/3. All right, so fractions. I don't like working with fractions. But there are some things that we can do. I mean, if you're good at adding fractions, I could even change this 5 into something over 3. So if you think about it, if you think about how many thirds go into a whole, there's 3 thirds in a whole, right? So 5 would actually be 15 thirds. So if that makes it easier, you could always do something like that to work with thirds. If not, we're just going to go ahead and we'll move all our x's to one side. In this case, I'm going to go ahead and move this is a 1x, remember here. So I'm actually adding 1x here and here first. So when I do that, I get 5 equals, if I have a negative 2/3, 1 is the same as 3/3. So if I have negative 2/3 and I'm adding 3/3, well, it takes 2/3 for me to get back to 0, and then I would have 1/3 extra, and then I would add 5/3 to that. Okay? All right. So then I almost have x alone. I've got to get this over there. So I am going to subtract 5/3. And this is when it's nice to change this maybe into a fraction. So remember that I told you that this was 15/3. So if I subtract 5/3 from 15/3, let's think about how many thirds we're going to have left. So 15 minus 5 gives us 10/3. So we have 10/3, and that equals 1/3 x. So this is something that we can use our fraction busters for. So, you know, I don't like all these thirds. I don't like messing with fractions. So what we're going to do is I'm just going to show you kind of what we can do to get rid of those. So we have these 10/3, right? And that equals 1/3 over x. So to get rid of those, I can just multiply everything by 3. So if I multiply by 3 on both sides, right? So kind of like 3/1. We get 30/3, which is 10, right? Because those 3's kind of cancel. And that equals just x, because 3/3 is 1, and 1x is just the same as x. So this is actually equal to 10. After all of that, it equals 10. So then we take the 10, we plop it back into one of our equations, which I like the one that's y equals 5 minus that x. So if we put the 10 right there, it's y equals 5 minus 10. So that would give me y equals -5. So x equals 10, and y equals a -5. You won't have one quite that hard on the test, but it's good practice for you. Finally, we've got our last question. I've got, you know, this Highland Park. They charge $7 admission. That's the starting point. So Playland Park, I'm just going to put PP, Playland Park. So Play Park. And then I've got it's 75 cents per ride. Let's call the ride X's. And then it's a $7 admission. So that's not $75. I better put a decimal there for 75 cents. And that equals the other one, which is 50 cents per ride. And we are starting at $12.50 admission. And so then I put all my x's to one side. I'm going to subtract the 0.50 over here on both sides. 0.50x, I should say, which gives us 0.25x plus 7 equals 12.50. Then if I subtract 7 from both sides, we get 0.25x equals 5.50. And if you take 5.50 and you divide by 25 cents, so 5.50 divided by 25 cents, that equals 22. So x is equal to 22. You take the 22, you put it into one of those equations. I'm going to pick that one. So I take 0.75 times the 22. So I'm going to multiply it by 0.75. And then I add 7. So I'm going to add $7 more. And that equals a grand total of 23. So y equals 23.5. So x is for the number of rides. So 22 rides, $23.50 for the cost. All right. So that one's kind of a hard one too. You're working with some decimals. If it was me, I would have used my decimal buster method right here to get rid of that. All right, make sure you check out the notes once again and you pause where you need to. Good luck.